Introduction.
Hello students. Today we will learn three-dimensional geometry. Do you know what three dimensions are? Teacher, in three dimensions we consider x, y and z axis. Very good. What is angle in between these three axes? Teacher, the angle in between the axes is 90 degrees. Well said. So let's move further. In this lesson, you will learn three-dimensional geometry. Objectives. At the end of this lesson, you'll be able to find direction cosine and direction ratio of a line, find equation of line in space, find angle between two lines, find shortest distance between two lines, find the equation of a plane, check the coplanarity of two lines, find angle between two planes, find distance of a point from a plane. Find angle between a line and a plane. Direction cosine and direction ratios of a line. If a straight line makes angles alpha, beta and gamma with x-axis, y-axis and z-axis respectively, then cos alpha, cos beta, cos gamma are called direction cosines of the straight line. Direction cosines are generally denoted by L, M, N. Any three numbers which are proportional to the direction cosines of a line are called the direction ratios of the line. If A, B, and C are direction ratios of a line, then A equals lambda L, B equals lambda N, C equals lambda N. Relation between the direction cosines of a line. If L, M, N are direction cosine of a straight line, then L square plus M square plus N square equals 1. Proof. Let O be the origin and P be a point whose coordinates are x, y, z such that length of OP is r, then x is equal to LR, y equals MR, z equals NR. From the distance formula, between O and P equals square root of x minus 0 square plus y minus 0 square plus z minus 0 square. So x square plus y square plus z square equals r square, name it as 1. Substituting, x equals LR, y equals MR, z equals NR, we get LR square plus MR square plus NR square equals R square. L square R square plus M square R square plus N square R square equals R square. L square plus M square plus N square equals 1. The direction cosine in terms of direction ratios are L equals plus minus A upon square root of A square plus B square plus C square. M equals plus minus B upon square root of A square plus B square plus C square. N equals plus minus C upon square root of A square plus B square plus C square. Direction cosine and direction ratios of a line. Direction cosines of a line passing through 2 points. Let L, M, N be the direction cosines of the line P1, P2, and it makes angles alpha, beta, and gamma with the x, y, and z axis respectively. The direction cosines are given as L equals cos alpha equals x2 minus x1 by d, L equals cos beta equals y2 minus y1 by d, L equals cos gamma equals z2 minus z1 by d, d equals square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Example. Find the direction cosine of the line passing through the 2 points 1, 8, minus 5 and minus 2, minus 9, 5. Solution. Let d be the distance between the 2 points and its value can be found by the formula given below. D equals the square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. D equals square root of minus 2 minus 1 square plus minus 9 minus 8 square plus 5 square. D equals square root of 3 square plus 17 square plus 10 square. D equals square root of 9 plus 289 plus 100. D equals square root of 398. D equals 19.94. Direction cosines are given as L equals minus 3 by 19.94, M equals minus 17 by 19.94, N equals 10 by 19.94. Equation of line in space. Equation of line through a given point and parallel to a given vector v. Select a point P0, the line L, and a non-zero vector v parallel to the line. The line L is then the unique line passing through P0 and parallel to vector v. Now P lies on L if and only if vector P0, P, is parallel to vector v. As vector P0, P is equal to vector OP minus vector OP0, which equals vector R minus vector R0. This condition is equivalent to vector R minus vector R0 equals T vector V for some scalar t. The equation vector R minus vector R0 equals T vector V is called a vector equation of the line L. Cartesian equation of the line. Let the coordinate of the point P0 be x1, y1, z1 and the direction ratios of the line be a, b, c. And the coordinates of point P be x, y, z, then the Cartesian equation of the line is x minus x1 by a equals y minus y1 by b equals z minus z1 by c. And if LMN be the direction cosine of the line L, then the Cartesian equation can be written as x minus x1 by L equals y minus y1 by M equals z minus z1 by N. Equation of line in space. Equation of line passing through two given points. Let vectors a, b and r be the position vectors of a, x1, y1, z1 and b, x2, y2, z2 and p, x, y, z respectively on line L. Then the vector equation of the line L is vector r equals vector a plus lambda, vector b minus vector a. Lambda belongs to real numbers. Cartesian equation of the line. The Cartesian equation of the line is x minus x1 by x2 minus x1 equals y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. Example. Find the vector equation of the line through 1, 2, 3 and parallel to vector 3 cap I plus 2 cap j minus cap k. Solution. Given vector v equals 3 cap I plus 2 cap j minus cap k. RO equals 1, 2, 3 equals cap I plus 2 cap j plus 3 cap k. Hence the vector equation of line is R equals cap I plus 2 cap j plus 3 cap k plus t 3 cap I plus 2 cap j minus cap k equals 1 plus 3t cap I plus 2 plus 2t cap j plus 3 minus t cap k. Angle between two lines. Let L1 and L2 be the lines passing through the origin O and with direction ratios A1, B1, C1 and A2, B2, C2 respectively. Let P be a point on L1 and Q be a point on L2. Then there are two directed lines, OP and OQ. Let theta be the acute angle between OP and OQ. Then the angle theta is given by cos theta equals modulus of A1 A2 plus B1 B2 plus C1 C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Let the direction cosines are L1, M1, N1 for the line capital L1 and L2, M2, N2 for the line capital L2. Then the angle theta is given by cos theta equals modulus of L1 L2 plus M1 M2 plus N1 N2. Important points. If the lines are perpendicular, that means if theta is equal to 90 degrees, then A1 A2 plus B1 B2 plus C1 C2 equals 0. If the lines are parallel, that means if theta is equal to 0 degrees, then A1 by A2 equals B1 by B2 equals C1 by C2. If two lines are given as vector R equals vector A1 plus lambda vector B1, vector R equals vector A2 plus mu vector B2, then cos theta equals modulus of vector B1 into vector B2 by modulus of vector B1 into modulus of vector B2. In Cartesian form, the angle theta between two lines is given as cos theta equals modulus of A1 A2 plus B1 B2 plus C1 C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Example. Find the angle between the pair of lines given by vector R equals cap I plus 5 cap j minus 7 cap k plus lambda 2 cap I minus 3 cap j plus 6 cap k. Vector R equals 4 cap I minus 8 cap j plus 2 cap k plus lambda 7 cap I plus 5 cap j plus 9 cap k. Solution. Given vector R equals cap I plus 5 cap j minus 7 cap k plus lambda 2 cap I minus 3 cap j plus 6 cap k. Vector R equals 4 cap I minus 8 cap j plus 2 cap k plus lambda 7 cap I plus 5 cap j plus 9 cap k. Comparing given equations with the equations vector R equals vector A1 plus lambda vector B1, vector R equals vector A2 plus mu vector B2. Here, vector B1 equals 2 cap I minus 3 cap j plus 6 cap k. Vector B2 is equal to 7 cap I plus 5 cap j plus 9 cap k. Then the value of angle between two lines is given as cos theta equals modulus of vector B1 into vector B2 by modulus of vector B1 into modulus of vector B2. Cos theta equals modulus of dot product of 2 cap I minus 3 cap j plus 6 cap k and 7 cap I plus 5 cap j plus 9 cap k divided by square root of 4 plus 9 plus 36 into square root of 49 plus 25 plus 81. Cos theta equals modulus of 14 minus 15 plus 54 divided by 7 into 12.44, which equals modulus of 53 by 87.08. Theta equals cos inverse 53 by 87.08. Theta equals 52.51 degree. Shortest distance between two lines. Distance between two skew lines. If two lines L1 and L2 are skew, that is, they are neither parallel nor intersecting, then a line L3 perpendicular to both the skew lines is called the line of shortest distance. If PQ is the line segment of L3, which meets the two skew lines L1 and L2, then PQ is called the shortest distance between L1 and L2. If the two skew lines are vector R equals vector A1 plus lambda vector B1, vector R equals vector A2 plus mu vector B2, then the shortest distance D is D equals modulus of dot product of vector A2 minus vector A1 and cross product of vector B1 and vector B2 divided by modulus of cross product of vector B1 and vector B2. If the shortest distance between two lines is 0, that means the lines are intersecting a coplanar. In Cartesian form, the shortest distance between the lines L1 x minus x1 by A1 equals y minus y1 by B1 equals z minus z1 by C1. L2 x minus x2 by A2 equals y minus y2 by B2 equals z minus z2 by C2. Is modulus of determinant row-wise first row x2 minus x1 y2 minus y1 z2 minus z1, second row a1 b1 c1, third row a2 b2 c2 divided by square root of b1 c2 minus b2 c1 square plus c1 a2 minus c2 a1 square plus a1 b2 minus a2 b1 square. Shortest distance between two lines. Distance between parallel lines. Let the two parallel lines L1 and L2 are given by vector R equals vector A1 plus lambda vector B, vector R equals vector A2 plus mu vector B, where S is a point on line L1 with position vector A1 and T is a point on the L2 with position vector A2 and vector B is the direction of each line. If TP is the distance between two lines, then TP equals modulus of cross product of vector B and difference of vector A2 and vector A1 divided by modulus of vector B. Example. Find the shortest distance between the lines L1 and L2 whose vector equations are vector R equals cap I plus 3 cap j plus 5 cap k plus lambda minus cap I plus 2 cap j plus 3 cap k. Vector equals 2 cap I minus cap j plus lambda cap I plus 4 cap j plus 5 cap k. Solution. Given vector R equals cap I plus 3 cap j plus 5 cap k plus lambda minus cap I plus 2 cap j plus 3 cap k. Vector equals 2 cap I minus cap j plus lambda cap I plus 4 cap j plus 5 cap k. Comparing the given equations with the equations vector R equals vector A1 plus lambda vector B1, vector R equals vector A2 plus mu vector B2, we get vector A1 equals cap I plus 3 cap j plus 5 cap k, vector B1 equals minus cap I plus 2 cap j plus 3 cap k. Vector A2 equals 2 cap I minus cap j, vector B2 equals cap I plus 4 cap j plus 5 cap k. Vector A2 minus vector 1 equals cap I minus 4 cap j minus 5 cap k. Now, cross product of vector B1 and vector B2 is minus cap I plus 2 cap j plus 3 cap k cross cap I plus 4 cap j plus 5 cap k equals determinant. Row-wise, first row cap I, cap j, cap k. Second row minus 1, 2, 3. Third row 1, 4, 5 equals minus 2 cap I plus 8 cap j minus 6 cap k. Modulus of cross product of vector B1 and vector B2 equals square root of 4 plus 64 plus 36 equals square root of 104. Hence, the shortest distance between the lines is given by equals to modulus of minus 2 minus 32 plus 30 by square root of 104 equals 4 by square root of 104. Plane. A plane is a surface such that for any 2 points A, B on it, the whole line segment AB lies on it. That is, every point on the line segment AB lies on the surface. Equation of plane in normal form. Consider a plane whose perpendicular distance from the origin is d not equals to 0. If vector ON is the normal from the origin to the plane, and cap n is the unit normal vector along vector ON, and let vector r be the position vector of the point P on plane, then the equation of plane, vector r with the unit vector n equals t. In Cartesian form, the equation of the plane, let vector r equals x cap I plus y cap j, j cap k is lx plus my, and z equals d, where L, M, N be the direction cosines of cap n. Plane. Equation of a plane perpendicular to a given vector and passing through a given point. Let vector A be the position vector of a given point A on the plane with respect to origin O, and let vector r be the position vector of any point r on the plane. If vector n is the vector normal to the plane, then vector n will be perpendicular to every line on the plane. So, vector n is perpendicular to vector AR. So the equation of the plane is dot product of vector AR and n equals 0, or dot product of vector r minus vector A and vector n equals 0. In Cartesian form, the equation of the plane is let vector r equals x cap I plus y cap j plus z cap k. Vector A equals x1 cap I plus y1 cap j plus z1 cap k. Vector n equals a cap I, b cap j plus c cap k. Then, dot product of vector r minus vector a and vector n equals 0 becomes a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals 0, where a, b, and c are the direction ratios of the plane. Equation of a plane passing through 3 non-collinear points. If r is any point on the plane with position vector r, then since a, b, c, and r are coplanar, so AR, AB, AC are coplanar. Therefore, dot product of vector AR and cross product of vector AB and vector AC equals to 0. Or dot product of vector R minus vector A and cross product of vector B minus vector A and vector C minus vector A equals 0. In Cartesian form, if vector A equals x1 cap I plus y1 cap j plus z1 cap k, vector B equals x2 cap I plus y2 cap j plus z2 cap k, vector C equals x3 cap I plus y3 cap j plus z3 cap k, and vector R equals x cap I plus y cap j plus z cap k. The equation of the plane is determinant row-wise. First row, x minus x1y minus y1, z minus z1. Second row, x2 minus x1 y2 minus y1, z2 minus z1. Third row, x3 minus x1 y3 minus y1, z3 minus z1 equals 0. Plane. Intercept form of the equation of a plane. Let O be the origin, and OX, OY, and OZ be the coordinate axes. Let the plane meet OX at O, OY at B, and OZ at C. Then OA is equal to A, OB is equal to B, and OC is equal to C. It implies that position vectors of A, B, and C respectively are A cap I plus 0 cap j plus plus 0 cap k plus 0 cap I plus b cap j plus 0 cap k plus 0 cap I plus 0 cap j plus c cap k. It implies that equation of plane is x by a plus y by b plus z by c equals 1. Plane. Plane passing through the intersection of two given planes. We know that the two planes dot product of vector r and vector n1 equals d1 and dot product of vector r and vector n2 equals d2 intersect along a line. The points on this line are common to both the planes. Further, the points that satisfy the equations of both the planes also satisfy the equation. Dot product of vector r and vector n1 plus lambda vector n2 equals d1 plus lambda d2, where lambda belongs to r. In Cartesian form, if vector r equals x cap I plus y cap j plus z cap k, vector n1 equals a1 cap I plus b1 cap j plus c1 cap k, vector n2 equals a2 cap I plus b2 cap j plus c2 cap k, then the equation of the plane is a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 equals 0. Coplanarity of two lines. If two lines vector r equals vector a1 plus lambda vector b1, vector r equals vector a2 plus mu vector b2 are coplanar, then their common plane must be parallel to each of the vectors vector a2 minus vector a1, vector b1, vector b2. That is, these three vectors must be coplanar. Therefore, dot product of vector a2 minus vector a1 and cross product of vector b1 and vector b2 equals 0. In Cartesian form, if the lines are x minus x1 by a1 equals y minus y1 by b1 equals z minus z1 by c1 and x minus x2 by a2 equals y minus y2 by b2 equals z minus z2 by c2, then the equation of the plane containing lines is determinant row-wise. First row, x minus x1, y minus y1, z minus z1. Second row, a1, b1, c1. Third row, a2, b2, c2 equals 0. Angle between two planes. The angle between two planes is defined as the angle between their normals. Let theta be the angle between two planes. Dot product of vector r and vector n1 equals d1 and dot product of vector r and vector n2 equals d2. Then theta is the angle between two vectors n1 and n2. Cos theta equals modulus of dot product of vector n1 and vector n2 divided by modulus of vector n1 into modulus of vector n2. In Cartesian form, if theta be the angle between two planes, a1x plus b1y plus c1z plus d1 equals 0 and a2x plus b2y plus c2z plus d2 equals 0. So, cos theta equals modulus of a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Distance of a point from a plane. In vector form, length of perpendicular from a position vector A to plane dot product of vector r and vector n equals d is given by, in Cartesian form, the length of perpendicular from a point P, x1, y1, z1 to the plane ax plus by plus cz equals d is given by example. Find the distance of a point 4, 2, minus 1 from the plane. Solution. Given vector A equals 4 cap I plus 2 cap j minus cap k. Vector n equals 3 cap I minus 4 cap j plus cap k. And d equals 10. The distance of the point 4, 2, minus 1 from the plane is equal to modulus of 12 minus 8 minus 1 minus 10 by modulus of square root of 9 plus 16 plus 1 equals 7 by square root of 26. Angle between a line and a plane. The angle between a line and a plane is the complement of the angle between the line and normal to the plane. In vector form, if the equation of the line is vector r equals vector a plus lambda vector b, and the equation of the plane is dot product of vector r plus vector n equals to d, then the angle theta between the line and the normal to the plane is cos theta. So the angle pi between the line and the plane is given by 90 minus theta, that is, sin 90 minus theta equals cos theta, and did you know Leonhard Euler was a Swiss mathematician and physicist, and he did great contribution in three-dimensional shapes and in their analysis. He made huge contributions to a wide range of mathematics and physics, including analytic geometry, trigonometry, geometric calculus, and number theory. Summary. Let us summarize what we have learned. Direction cosine of a line is defined as the cosines of the angles made by the line with the positive direction of the axes. Three numbers which are proportional to the direction cosines of a line are called the direction ratios of the line. If L, M, N are direction cosine of a straight line, then the equation is called a vector equation of the line L passing through a given point and parallel to a given vector V. In Cartesian form, if vectors A, B, and R be the position vectors of A, x1, y1, z1, B, x2, y2, z2, and P, x, y, z respectively on line L, then the vector equation of the line L is vector R equals vector A plus lambda vector B minus vector A. Lambda belongs to real numbers. The Cartesian equation of the line is x minus x1 by x2 minus x1 equals y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. If A1, B1, C1 and A2, B2, C2 be the direction ratios of a line, then the acute angle theta between the two lines are if the two skew lines are, then the shortest distance d between the lines is, in Cartesian form, the shortest distance between the line is the distance between two parallel lines is, in vector form, the equation of the plane which is at distance d is where cap n is the unit vector normal to the plane. In Cartesian form, equation of the plane is where L, M, N be the direction cosines of cap n. Equation of a plane perpendicular to a given vector and passing through a given point is, in Cartesian form, where A, B, and C are the direction ratios of the plane. Intercept form of the equation of a plane is, if the lines are, and then the equation of the plane containing lines is, if theta be the angle between two planes, and then theta can be written as length of perpendicular from a position vector A to plane is given by the angle phi between the line and the plane is